And salutations, I'm Gil.
And I'm Gil, and this is Strategic.
Hey, welcome. We have an interesting topic today. We are going to talk about a topic that preppers sometimes like to talk about. The movies love to talk about when it comes to emergency preparedness. Nuclear disasters,
Yeah.
right? I mean,
That's a fun one.
I get a blast when I talk about it, pun intended. All right, a little bit about my background. Besides the NBC training that I received multiple times in the Marine Corps, nuclear, biological, chemical, I also have been trained and worked as a collateral part of my duty, but radiation safety officer with industrial nuclear sources at a number of facilities, chemical plants, mining, and all that. So I have a little bit of a background in radiation, have used the equipment, and know the concepts. So that's what I want to talk to you about, because Gil does not know a lot about radiation, so that's what we're gonna be covering today. So the first thing is understanding what we mean by radiation. All right, two basic types of radiation: ionizing and non-ionizing. All right. So, and I'm also looking at you guys too sometimes. I hear a lot of people talk about radiation, especially like with microwave ovens.
Yeah, is the microwave gonna give me cancer?
Oh my gosh, how about the power lines overhead? All right. So, and I'm not saying that those are risk-free.
Yeah.
Okay. I don't even want to get in that discussion because I don't have the depth of knowledge on those to do that.
Yeah.
Right. But those types of energy are called non-ionizing radiation. Ionizing radiation means that this energy, this power, will be stripping electrons from the molecules in your body. I mean, crap.
Yeah.
That's pretty bad stuff, and that messes you up. All right. So before we can continue in the different types, what types of radiation, because it's not just yes or no radiation. There's different types. Where might you see a threat from radiation as an emergency-minded person?
If you're near a nuclear power plant.
If you're near a nuclear power plant, like they had Chernobyl, they had the one in Japan.
Yeah, meltdown.
3 Mile Island, way back before your time, 1979, I think that was. I'm not overly concerned with that, and I'll tell you why. It's a localized event for any prepper, any emergency-minded, actually anybody else. If you have that kind of disaster, get in your vehicle and go away.
Yeah.
Okay. And we're going to talk about why you can do that in just a moment. So I'm looking for more broad-based type events. Nuclear war, a series of dirty bombs, right, from terrorists.
Yeah.
Those type of things. Nuclear bomb, if you get hit with the bomb, boom, you're dead. Okay. The biggest concern, if you're not immediately impacted from the bomb, is the fallout. All right. What is fallout? All that stuff that gets irradiated goes up into the air. All right, falls back down. Heavier particles will be closer towards the epicenter of the bomb, and the lighter particles will be farther away. Now, if you're traversing an area, let's say you're near that city that you're near, and you decide, boom, it got hit, and you're going to come over here to us, right? Fallout would be something, depending on your route, that you would want to be aware of.
Yeah.
All right? How do I know about fallout? Okay, so before we get into the different types of radiation, there's 3 ways to protect yourself from radiation. Okay, and you want to control any one or any combination of these. All right, time, distance, and shielding. Okay, limit your exposure. Being exposed to radiation does not automatically mean you're going to get cancer, get sick, and all that other stuff. Depends on the level. All right, so you reduce the time. If you realize, oh my gosh, there's radiation, shorten that time. How do you shorten the time? Leave. Yeah. All right, leave. This area is contaminated. All right, distance. I know that area over there is contaminated. I'm going the other way. And then shielding, proper chemical suits and things like that. Right. So, time, distance, and shielding. That's how we protect ourselves. But all radiation is not the same. We have X-rays, and that's just pure energy, right? So X-ray machines, So as a prepper in an emergency situation, we're unlikely to come across X-rays. What we're likely to come across are alpha, beta, and gamma particles. Okay? And it's good to understand the impact of those because it'll help us to understand how to protect ourselves. Alpha particles are the largest, and some people think they're the least hazardous because they can actually be stopped by our clothing, right? A thick sheet of paper can stop an alpha particle. But if it's big and has mass, think about your ammunition. All right, and if it's already moving and is large, it's a shotgun slug.
Yeah.
How hard is it to slow it down once it's already moving?
Yeah.
It's harder,
It's harder.
because it has more mass. So, if an alpha particle is going to impact you, it could do a lot of damage. But you're thinking,
Just hold up a sheet of paper and I'll be okay.
I'll hold up a sheet of paper, I'll put my clothes on, right?
Yeah.
Something. All right. What happens if you're in an area and there's fallout and there's alpha radiation and you break out your sandwich and you eat it and you get alpha radiation on your sandwich and it goes inside your
Now
stomach.
it's in my body.
Now it's in your body with a lot of mass,
Yep. And there's nothing protecting it.
nothing protecting it, and it's going to do some serious damage. So it matters, even though it's alpha and you can block it. Beta is smaller and requires a little bit more shielding. And the worst one that people really concern themselves with is the gamma radiation. That's where you need the lead suits and all that. That's really considered the most dangerous. But I mean, it's the smallest and all that. So alpha, beta, gamma, there's differences, and you're likely to find a combination of those. So different types of radiation means possibly different types of threats, but that's what we're likely to come across. Okay, that's ionizing radiation. So one of the first things we want to do is be able to detect the radiation, right? Time, distance, and shielding. If I don't know it's there, then I can't take measures to protect myself.
Yep.
Right? So I have some devices here, and this is a RADEX meter. Short little meter, very lightweight, and I mean, what's it say on it?
10.
10. All right, 9, 10. So this is microrems per hour, very small. So what is what's a safe exposure? Well, the thing is that the regulations are so complicated, and the purpose of this for all you guys is not to be complicated, to try to simplify this. Occupational exposure that is considered the maximum safe level is 5 rems a year.
Okay.
All right, so it's kind of a lot. So this is at 10 microrems. There's not a lot, but you might be thinking, there's evidence. Whoa, there's radiation here, right? I got news for everybody. There's ionizing radiation everywhere.
Yeah.
You know what they call that?
What?
Take a guess.
Sunshine?
Background
Oh,
radiation.
yeah.
It's called
okay.
background radiation.
Yeah.
All right. So, for this meter, it's lightweight, it's easy, it's not very expensive, a couple $100. And it's giving kind of an instant reading, but it takes time for it to read. So if a person were using this, obviously you want to read the instructions, get familiar with it, and practice with it. But this is one way for me to determine the radiation level. Okay. My favorite is this old civil defense unit. This thing's heavy. Pick this up. Compare that in weight.
Oh, yeah.
It's got a whole bunch of batteries in it. So for this thing here, it is relatively easy to use. I've got a dial here. I come over here, I do a circuit check, and boom, circuit check. Is it good?
Yep.
All right. And then we do want to be concerned with background radiation. I don't want to detect background radiation. So I get to a safe area that I know is safe, and I've got a 0 button. Oh, here we go, 0. So I go on the 0, and I move that arrow till 0. All right, so now I have zeroed this. Now I can go in a potentially contaminated area, and this has a multiplication factor times 0.1. This is just a 1, and you can see from the arrow, very low.
Yeah.
Virtually nothing. Okay, so I multiply by 0.1, so that is a as it settles in, it's 0.04. 0.04. Very small amount, just background radiation. It's normal. We all live with it all the time. But if I'm walking through an area and this starts going off, and I got it really low, then I adjust it. And if I'm at times 100 and it's still going, that tells me I need to go change my underwear, but I don't in a safe area. Get out of there. It'll help me understand just how much is in here. So this is in rems per hour.
Oh, that's micro rems.
That's micro. That's much more sensitive than this. This is still pretty sensitive. It's going to pick it up, but so that is that's much more sensitive. I like this. It's a very sturdy piece of equipment.
Yeah, turn it off.
Right. Let me turn that off. All right. That's 2 methods, but 1 is none and 2 is 1. But radiation, I think 3 is fun. All right. So I also have what is called passive detection. All right. So let me show this to you. So basically, you've got this bar in the middle, right, that will change color when you're exposed to ionizing radiation. Right? And you match it up with that reference color, and that will tell you what you're being exposed to. And even if you don't have any of those, you take something like this, you throw it in your pocket, you hang it on your pocket as you're going through an area after a disaster, and you look down occasionally and it starts to change color, and you're like, oh, I don't want to be where I'm at. All right. So it's going to be less immediate. It's going to be less accurate, but it'll give you some detection.
It's a lot cheaper too, I'd imagine, right?
Oh, yeah. It's real easy, and you can get a bunch of them. They come in this little packet here. It's called RADTriage. RADTriage. Okay. It's an emergency dosimeter. So I think everyone ought to have these in their bug out bags. If radiation is a threat, if it's on your list of things to be concerned with. All right, so we have detection, right? We have an understanding of radiation. What else are we going to do? Is that it? We're just screwed?
Nope. Now we're going to protect ourselves, right?
Protect ourselves. Several different things we can do. So what I have are these IOSAT Iodide tablets. Basically, these will help protect us so that we don't absorb the radiation, and without the thyroid is what absorbs a lot of the radiation. Is what makes us sick. This will help the thyroid from absorbing the radiation. If you're in a situation, let's say your nearby big city gets nuked, boom, right? Reach in your bag, take one. Just take one. Have your wife take one.
Yeah.
Right, and then you're going to follow the instructions. And I don't remember how often you can take them. Let's see. But here's the directions right here. One tablet daily. All right. But if you even if you're near a power plant, and that's your risk, boom, sirens go off. There's a meltdown, or take one. One's not going to hurt you.
Yeah.
Take one and get out. It will really help you from getting the exposures, some of the harmful exposures.
Yeah.
From
it
radiation.
only helps some, right? So it's not like it's not a replacement for a suit, right? So the radiation still can damage the cells in your body.
Sure.
It helps prevent
the thyroid
from
which
absorbing
absorbs the radiation. Right.
So it reduces that impact.
Yes.
Okay.
So, so that is one device, one option. Another option is using proper respiratory protection. If you're in an area and you have to be in that area, and let's say you've got the fallout, it's all on the ground, maybe you've got a Tyvek suit or something. That's all you have. Remember, you got your alpha particles out there, right? What's the big risk with the alpha particle?
Get inside your body.
Getting inside the body. How do you prevent that from getting inside the body? Respiratory protection, right? Which respirator? Well, with radiation, you want to make sure you've got the right respirator. And that will be a HEPA cartridge. They're magenta colored, kind of an off weird purple. They're magenta colored, but you do want to have a half or full face respirator with those magenta, with those HEPA cartridges. They will filter out those radioactive contaminants as well. So if for some reason, maybe you're evacuating the area, right? You take your iodide pills, and maybe you want to throw the respirator on, and so that you don't breathe in the fallout as it's coming out as you try to evacuate the area. So there's things that you can do to minimize the impact. Fact of the matter is, ionizing radiation is scary because it is so deadly, and even with all these things, a person still could suffer impacts. It still could be fatal, but these are steps that those of us who are readiness-minded people, those of us who think about how to protect ourselves in these situations, these are steps that will help us in a nuclear event to give us a better chance of survival. All right, questions?
Not too much, and we talked about that. So, part of the kit, I guess, to build, right? I guess I would start small with cheaper things like the iodine and the card, and then what Tyvek suits, respirators, and then eventually get this.
But you already have the respirators.
Yeah, and I already got Tyvek suits,
because those are also important
for other stuff. Yeah,
for disease and biological type stuff. So you've got that.
So I take it there's no real commercial radiation suit to get, and it probably wouldn't be cost effective anyway, right? The idea would be to leave and not stay there suited up.
Yeah. I mean, you really don't. If there's an area with fallout, you don't want to be there.
Yeah.
If there's a risk of nuclear contamination where you're at, or any of you guys are at, part of your plan needs to be get out of there. I mean, that's just. I mean, you're just not going to win.
Yeah. No, there's no.
I don't care what kind of suit you have. The radiation is going to outlast your suit. So all the suit does is gives you that shielding.
Yeah, buys you time.
Right?
Yeah.
So time, distance, and shielding. So it gives you, I don't know what they use nowadays actually, but we had the charcoal mop gear that we used when I was in the Marines. And they don't last indefinitely, right? It gives you shielding. At some point that shielding will break down. So you remember in the x-rays, they give you a lead apron.
Oh, yeah.
That lead is a shield.
Yep.
That's it. So you want to minimize your time that you're exposed. You want to maintain distance. The greater the distance, the less the radiation, and shielding if you have to be exposed, some type of shielding. Another option, if you wanted to, like we're talking buying time, is if you've got a nuclear power plant nearby, concrete walled building, like maybe a shop. You have a shop in your house. You still have the windows. That would be an issue, but you'd have to be able to block those somehow. But concrete gives you really good shielding. If you have that's what bomb shelters are underground, because the ground is the shielding.
Is there any big difference on how you'd respond between dirty bomb and nuclear bomb, right? Thermonuclear versus dirty bomb, or really the hazard? Once you survive the initial blast, the hazard is the same.
Yeah,
right?
well, a dirty bomb is not really a bomb per se. Basically, it's a conventional bomb with radioactive device.
Yeah, so it just spreads it everywhere.
Yeah. So the real difference from my perspective is the scope of the disaster. A nuclear bomb would be a much greater scope.
Yeah.
But as far as on the nuclear side, if for some reason somebody had something against Western Tennessee, which I can't imagine they would, I would still immediately take my iodide tablet, right?
Yep.
I'd give one to your mother. I would break out my badge and I would put it on me.
Yep.
Okay, I mean that's right off the bat. I want to know if somehow I'm exposed if that's near me. Then I would get my meters running. And this one here, particularly lightweight, easy, I would keep that running until I determined that there was no risk.
Yeah. Oh, I had a question. So, I know in the chemical industry, you got a release. Important to figure out where the prevailing winds are, and
Right.
go diagonal and upstream, right, to get away.
Right.
I think it'd be the same thing if there's fallout, let's say from major city.
So
If
what
you're
is
gonna
fallout? Fallout is contaminated particles, right?
So the wind would carry it.
So the wind does the wind does matter. So there are general wind directions. You know, the general wind flow.
Yeah.
Like Memphis is to the west of me, right?
Yeah.
So if when Memphis got nuked, the general direction would be for that stuff to come towards me. Now it's a good enough distance where I can't imagine a blast big enough that would.
Yeah, but it's
Yeah,
I guess
but the direction would be here. So if you're on the backside, your distance would be less. Your safe
I guess
distance.
that'd be one of those things. If you're living in an area where you're worried about that, or if that's on your radar, you should have an idea of generally what the winds are. Probably check it the day of, right? Because it'd be on the news.
Let's take
and don't go downstream.
Sure. Let's take it a different way. Let's take the same problem, but with a different twist. You're south of Memphis, and I'm picking on Memphis just because Memphis is nearby. You know, we love Memphis. We're not trying to pick on it, but that's the example. You're south of Memphis, and your plan is to get north of Memphis, right? Forget about the river. Let's assume crossing the Mississippi is not an issue in this scenario, right? So you need to get to the north. You're not going to go through Memphis because it just got nuked, right? In the scenario, it really did not get nuked. Okay. Would you go to its east, or would you go to its west? Based on prevailing wind conditions.
I don't know what the prevailing winds are.
Well, prevailing winds are generally
west, east?
the prevailing winds are to the east,
Okay.
coming from towards here. So you would go to the Arkansas side.
Yeah, go
Typically,
east.
if you really didn't know,
Yeah.
because you wouldn't have to go that as far around. The fallout would likely blow away further towards Nashville area, towards the east, typically. So understanding that, so that's a great question. Understanding that, I say, I have to get around this city. I have to get around Chicago. I have to get around Nashville. I have to get around Atlanta, whatever city it is, right? So part of my plan is, gosh, if there's a nuke, all my paths take me around that side, but the prevailing winds say I would be downstream and I would be sucking up a lot of fallout.
Yeah.
So I need at least one of my paths to get around a city that would be on the low likelihood side for prevailing winds. So great discussion, great comment. All right.
I think that's it. Yeah.
All right, thanks. So I know there's an awful lot. Some people that are nuke experts will say, oh, you missed this, you missed that. Yeah, we missed a lot. We're just talking about the average person taking some steps to prepare themselves. So I'd like to know what you guys think. Leave your comments and leave any questions that you have. And I hope that this was helpful. And I will leave you some links on how to get some of this gear if you guys want to get that. So stay safe, stay unradiated, and stay prepared.